Swayam Prabha. Digital India. Educated India.
Dear students, welcome back to the class on understanding the impact of vegetation and water bodies in enhancing indoor thermal performance. Last time we had stopped with this class where we saw that certain researches have indicated that indirect evaporative cooling can offer thermal comfort by even up to reducing 2.5 degrees centigrade of indoor temperature depending on the outdoor condition. The traditional spring houses in Iranian architecture have always used water bodies to kind of cool the environment. There are examples of fountains kept inside a room, and by virtue of the air circulation, they cool the air. There have been examples of water body adjacent to openings, and when warm air flows over it, it gets laden with the moisture and the cool air comforts people inside. Placing pools or water features near windows or in courtyards pre-cools the air through water evaporation, extracting heat and enhancing cooling. In public buildings, pools and fountains combined with cross ventilation and cooling. Cooling towers can pre-cool ventilation. It can reduce mechanical system workload. This is effective in hot and dry climate, and evaporative cooling proves essential for energy efficient cooling strategies. Placing pools, ponds and water features in close proximity to windows or within courtyards serves to pre-cool the air entering the house. The process involves the evaporation of water, which extracts significant amounts of heat from the surrounding air. In public buildings, incorporating pools and fountains can contribute to cooling, especially when combined with cross ventilation through strategically positioned openings. Additionally, cooling towers can be employed to evaporate and pre-cool ventilation air for one or more air handling units, thereby reducing the workload on mechanical cooling systems. It is important to note that evaporating cooling is most effective in hot and dry climate, because in warm and humid climate, the air is already humid and laden with moisture, and hence adding more moisture to the already moist air will only increase discomfort unless it is handled prudently. In this picture, you can see that water body is enclosed inside a building and it is enclosed inside a courtyard. The air which passes over the water body gets cooled, and if there are openings, the air moves and causes ventilation due to the cool air. Here is a case where the spray devices and screens have been used. What are spray devices? Spray devices are small devices which spray mist. So, this is actually mist which is sprayed, and the breeze passes through this misty air, and what you get is a air which is laden with moisture. The shade water bodies to further reduce temperature of the water and enhance its capacity to absorb heat from incoming air, and this air cools the building and it rises and escapes through the shaft, solar chimney. So, evaporative cooling can be made more efficient by coupling it with solar chimney to increase air movement and velocity through the building. This is also been used in the Iranian houses because the wind catchers along with the water bodies help in keeping the indoors cool. Now, let us look at the term plant carbon sequestration. Plant carbon sequestration is a process where plants absorb carbon in photosynthesis, storing it in structures and soil for nutrient cycling. Carbon is transferred to the soil through roots and litter, forming organic matter through microbial breakdown. Nutrients released support growth of other plants, and some carbon is naturally returned to the air during decomposition. In simple terms, it is the process where plants absorb carbon in photosynthesis, store it in its structures and soil for nutrient cycling. Some carbon is released naturally. So, the processes involved include number 1, carbon absorption. Plants take in carbon dioxide during photosynthesis. So, plants, trees, grass take in carbon dioxide during photosynthesis. Second step is incorporation into plants, that is, the absorbed carbon becomes part of the above ground shoots and below ground roots. So, the absorbed carbon is used for photosynthesis as well as in the roots. Third is contribution to soil. Carbon is transferred to the soil through roots and litter. So, the leaves that fall down becomes litter and it decomposes. This organic material or organic matter goes as labelli seed pool, and the litter gets partly decomposed, while some part of the litter gets converted into lignin, cellulose and hemicellulose. Now, in the microbial breakdown, soil microbes break down plant material utilizing carbon from roots and litter. So, the soil microbial community, it breaks down plant material using carbon from roots and litter. The soil and food web works in such a way that other soil organisms consume microbes and byproduct, creating a cycle. So, this cycle gets created. The nutrient release happens during the breakdown of plant growth and the carbon returns into the air during decomposition due to respiration. So, from human respiration, carbon dioxide is further released into air. Now, let us look at plant functional traits and diversity. Understanding plant functional traits is essential for designing landscapes to capture and store carbon. Plant traits, including functional traits and performance traits, independently influence a plant's fitness and overall performance. These traits, such as growth form and internal processes, impact size, survival rates and seed production, contributes to functional diversity. Diversity in functions play a crucial role in complex adaptive systems, especially when designing landscapes to capture and store carbon. To understand the role of functional diversity, the following components must be understood. First is plant traits. This is defined as independently measurable features of a plant. They impact performance, which in turn affects the plant's fitness. So, there are functional traits, and these functional traits are characteristics like growth form or internal process which indirectly influence a plant's fitness through effects on whole plant performance. These include the leaf area, the rooting depth, the amount of nitrogen it can intake. Whereas performance traits are direct measurements of an entire plant's performance, and it includes size, survival rates and seed production. So, here the performance traits depends upon the growth rate of a plant, its ability to survive and its ability to regenerate and reproduce itself. For example, a plant with a functional trait of a large leaf with photosynthesis more carbon and have energy to grow faster, and that a performance trait it is directly linked to, then will it have increased fitness. So, functional trait leads to performance traits and that leads to plant fitness, because plant reproduction and survival gets increased because of the reproduction capacity. So, leaf area, rooting depth, nitrogen uptake are all measurable features which affect the growth, reproduction and survival. While direct measurement of plant performance and fitness is growth rate and its ability to survive and reproduce. The next important criteria is plants, like people, can feel stressed. Stress for them means not getting enough light or water or nutrients. Some plants are like competitors. They thrive in good conditions. Stress tolerators have smaller leaves to survive through tough times. Survive during occasions where less water is given, or for example the plantation on windy beaches, it's under a